All right. Hello again, BlackHat. Our today's talk is the final asterisk chapter, Unlimited Ways to Bypass Your macOS Privacy Mechanisms. My name is Wojciech Reguła, and I am head of mobile security at Securing. I'm an author of Certified iOS Application Security Engineer course, and I'm mostly focused on iOS and macOS application security. And somebody of you may also know me from my blog that I run in my spare time, which is wojciechreguła.blog, where you can, of course, read about Apple security.
My name is Csaba Ficl. I currently work at Kanji as a principal macOS security and researcher. Before that, I created a training for macOS pen testing and exploitation. Even before that, I worked as a blue and red teamer. I do bug bounty also as a hobby. Currently, I have like 80 plus CVs from Apple, and I also run a blog on Apple security.
So this presentation is a research continuation that we are doing for last 4 years or something. Yeah. Last 4 years, the time passed fast. And we presented our first TCC talk on BlackHat US 2021. That was 20 plus ways to bypass your macOS privacy mechanisms. And after this talk, we found, again, 20 more TCC vulnerabilities. And that resulted in our second BlackHat talk, which was knockout win against TCC, aka 20 plus new ways to bypass your macOS privacy mechanisms. So we wanted to create the third presentation because we found another 20 vulnerabilities in the TCC. And just not to be the same, this title is different. So it's not a 20 new ways to bypass your macOS privacy mechanisms. And the plan for this talk is that because this is the third edition of this TCC talk, I'm just quickly remind you on how this all TCC and privacy fundamentals work. Then we will go through TCC bypasses. Quick spoiler, we did again some TCC bypasses with simple grepping, so stay tuned. At the end, Csaba will talk about dead and dying techniques, and we will cover also the TCC and security in general improvements in macOS Sonoma. So to quickly introduce you to privacy fundamentals, that will be just a quick recap, quick reminder. So on macOS, the most crucial, let's say, mechanism is system integrity protection is turned on by default. And on macOS, whenever you are root, you are not a GAT. You cannot do everything with your Mac if the system integrity protection is turned on, because system integrity protection, which is based on Sandbox kernel extension, so it's a really low-level mechanism, it restricts it restricts access to many directories, to files. It will also deny a debugger where you would like to debug or inject code to Apple-signed processes. So as the name says, it protects the system integrity. And the very important thing to understand is that even if you have root, you cannot do like inject to Apple processes to bypass TCC. This is all protected by system integrity protection. And when SIP is turned on, the TCC comes into play. So that's why it's also really important to have the SIP enabled for all the time. And the TCC stands for transparency, consent, and control. And the main thing that TCC does is it protects users' privacy. And because SIP will protect the TCC databases where all the permissions are stored, not even root should be able to approve TCC permissions. Whenever your application wants to get access to privacy-sensitive resources, you will see such a prompt. And Apple in here wanted to make sure that there is a clear user consent wherever the user clicks the allow button. So even if you are root, you should not be able to access privacy-sensitive resources without getting the user clicking allow. If you find a way not to spawn this prompt and get access to privacy-sensitive resources, you probably find a 0-day. And the interesting thing is from macOS Ventura, the TCC protects also containers of sandboxed apps. And this is a new feature introduced recently. And the TCC protects a lot of privacy resources now. As you can see, every picture shows another resource, and the number is still growing. And TCC, in general, became really, really big. If you go on your Mac to settings and privacy and security, you will see plenty of resources that are now protected. And even if you go to automation, you will see that now you can specify which particular app can control another particular app. So it's really granular. And because the TCC mechanism itself grew that much, the attack surface, of course, is big also. So there is a lot of ways you can play with TCC and probably find some more vulnerabilities. So let's now talk about the TCC bypasses.
Yeah, so let's start with some easy one, with some info leaks. So it's all started with me reading a blog post back in 2020 about a macOS database which contained basically a whole lot of private data. Now, you would expect like your contacts information, which is considered private data, is inside the address book directory, and it's protected by TCC. But turns out that your contact details are also on like 5 other places on the file system, and Apple didn't think about this. So I started to grep for private information on the file system, and it just was all over. As of today, I think I submitted like 30 info leaks. Apple does a minimum payout, $5K US for a vulnerability, and TCC leak is considered vulnerability. You can do the math, how much a grep worth. File system leaks are going away because I think we found most of them nowadays, but logs are the new place to search for. So some notable leaks: the key value service database on the file system contained email addresses, known Wi-Fi hotspots. The Game Center cache database was really nice because when you start Game Center, it basically made a copy of all of your contacts and all of their details. So you could just access the database and you get full contact information. The parsec, this was a fun one. So this daemon created very short-lived cache files. So I think grepping this was a bit of luck. Like they lived for a few minutes, and they actually logged your geolocation, so you could find the actual user location. And it also did a keystroke logging in Safari. So whatever I typed in Safari, it was keylogged in a cache file. That was like a system-provided keylogger. Pretty nice. Screen time core, these logged phone numbers in the logs. Maps, this was also really fun because if you started Apple Maps with a GPS coordinate or a location of your choice, it logged the distance to that location from your current location. So with opening a couple of coordinates, you could do either triangulation or some other calculation, and basically you could precisely locate the user based on the logs. But logs in general, so Apple tries to filter out private data from the system logs. So they mark it as private in the logs, and most of them are redacted. You can enable it back with a user profile, but the problem with user profiles is that it requires a lot of user interaction to install a profile. So as an attacker, you cannot really do that. But it turned out that if you install this profile, at the background, the system, the only thing it will do is enable a setting in the logging preferences, and basically it will enable all the private logs. So you just restart logd after setting the preference, and you get all of the private data in the logs. As we see or so, it can include a lot of data.
Yeah, and grepping is the hobby that we share with Chaba. and this vulnerability was also found in the logs, but to be more clear, it was in syslog. So the weather application, to create a forecast for you, it must know where are you located, right? So it sends your location to the Apple server, and the forecast is returned from the server. But the problem was that whenever the internet connection was broken, the full error was locked. And the full error included your location because it was locked. What was locked was the full HTTP request. So you could just break the internet connection and get your location without getting consent for the location permission. The second leak, also in the logs, was in iMessage. So whenever you opened iMessage, all the emails of contacts you chatted with are just locked. So it was that simple.
So that's about leaks. Let's get into some real stuff, because we are here for generically bypass TCC. So in the past, it was a common technique to change the user's home directory with a custom TCC database. So one of the TCC databases sits in the home directory in a specific folder. And by changing the home directory, we could drop basically a new TCC database with new permissions. Now, this was pretty well closed down by Apple. But there was one thing missed. We could still create a new user on macOS with a custom home folder, and basically we could drop a custom TCC database. So the problem was that back in macOS Ventura, a TCC entry, even in the user TCC database, was still kind of global. So if you allowed terminal to access your documents, it allowed it to access every other user's documents as well, assuming you were root as well at the same time. It was changed in Sonoma. So in my experience in Sonoma, if you grant terminal access to your documents, terminal still cannot access other people's documents. So the steps to actually exploit this, we create a new custom TCC database. We either create a new user or we enable the root user, which is disabled by default with the database. Log in as the new user. We steal whatever information we want, and we reboot. Now, this can be entirely automated. The way I will show it in the video, but the first few steps will be very quick. So essentially, I enable the root user with the custom TCC database. I install some auto-run scripts, which will steal the other user documents. I also enable auto-login, so I don't need to interact with the GUI. The root user will log in, steal the data, remove auto-login, reboot, and basically we are back to the user. So this is what we actually see here. We have a secret document at my user. And of course, to create a new user, I need to run as root. That was the exploit. Now the system reboots. And because auto-login is enabled, we will not see a prompt for the user. So right now it's just a blank screen. Basically in the background there is a process which is grabbing that secret txt. It's done. It removes auto-login, and now it's rebooting again. And once it's back, we can log in with the user. And so I log in as back as root, just to verify that I got the document. So the next generic bypass was used by the Safari Sandbox broker process. Safari Sandbox broker is the process which is responsible for unzipping zip files when you download them with Safari. Now, there is a feature on macOS or in Safari that it will auto-open save files, like unzip zip files. This is the first feature I think you want to disable on macOS for your own security. And this process has full disk access permissions. So basically, it means that it can access all of your private data. I don't know why it needs that, but it has it. So the way the unzipping process happens is this process will create a directory inside the downloads folder named filename.zip.download, download the zip file there. Then it will create another directory with 6-character random name and extract the contents into this directory. Now, how we can exploit this process to drop our custom TCC database to the user, because this is our goal. Again, with full disk access permissions, we can override the TCC database. So we create a large zip file, like a really large one, to actually slow down the decompression process. And we add our custom TCC database into this file. Then whenever a user downloads a zip file, we quickly overwrite it. Although Safari will continue to write to this file, because after the zip trailer, everything will be considered as junk. It's not a problem. And whenever Safari creates this 6-character long directory, we replace the directory with a symbolic link pointing to the TCC database folder. And so the third step is a race condition, but by having a large zip file with large files, it will be slow enough that we can trivially win it every time. And once the extraction is done, our TCC database will be overwritten. So this is demo, so we can see that terminal has access to the downloads folder. This is a prerequisite because we need to operate on the downloads folder. We start our exploit. It will start creating like 1.5 gig random content file. It's actually pretty slow, so I will speed that up. So it's done. I think it's still creating it. And whenever it's done, yeah, it's done. I will start downloading a zip file. And the exploit will detect the zip file. It will overwrite it. And now we are waiting for the extraction to start. Yeah, I also downloaded a large zip file, so it was slow. The extraction is happening, so we replaced the folder with a symbolic link, and we can see that all of our files are being extracted into the TCC database location, as well as the new TCC database. So it was dropped, that's done, and now if we refresh the permissions, we can see that now terminal has all sorts of new access. And the third generic one is using an installer. Install Assistant is the macOS installer you can download from Apple. Now, the good thing about Apple signed installers that they will be run with the system installed process, and that process has SIP bypass permission, so it can write to SIP protected locations. It also has the heritable part of this write, which means that any of the child process will inherit that permissions. So these packages has often installer scripts inside, which means that all of those scripts we run with zip bypass permissions. So if those scripts have issues, we can potentially bypass zip. Now, it turned out that all of these packages had this link shared support bash script inside. This is like a 15-line script containing 3 different vulnerabilities. I highlighted 2 of them. The first one is the ln command, which creates a hard link. So what it did, it took the package name, the package path, which is under our control because we installed the package, and linked it to shared support. Now, the way we can exploit this is we can replace the package with a symbolic link pointing to a zip-protected file, and in that case, a hard link will be created to this zip-protected file. And because zip protection is based on file paths, we will be able to overwrite or modify this file through the new hard link. Now, interestingly, the last line was also an issue because what it also did is removed the restrict flag from the file, which means it removed zip protection at all. So even if we wouldn't have the hard link, zip protection was removed from the file, so we can just operate on it and overwrite. So we could either target the TCC database, or I choose the Hello application plist file, which is considered as another TCC database in a plist format. So just here's a quick demo of this. I try to list the desktop folder with terminal, and I don't have access to it. Then I log in as root to access other locations as well. And I try to access the main TCC database. Now, this database is protected by zip as well, and we cannot even read it if we don't have permissions. So now we run our exploit. This is luckily pretty fast. We place the symbolic link, and now we wait for the installation to finish. And that's done. We updated the Hello application list plist, and now we can access all the other files because I granted full disk access rights to terminal.
Okay, my turn. So I spotted a command line tool, CPL diagnose, which diagnoses mostly iCloud-related services. And as you can see at the screenshot, it is heavily entitled with private Apple permissions. Even there is a ComApple private TCC allow entitlement, which looks like a sweet spot to reverse engineer. But without reverse engineering, that tool requires root permissions to be executed. But please keep in mind that when system integrity protection is turned on and TCC is also on, even with root, you should not be able to access user-sensitive data, right? So now let's read it together, the output of this command line tool. Because you will see that even Apple engineers knew that this tool can be potentially harmful. The photos diagnostics may contain some of your personal information, that's good, including your location, IP address, crash logs, iCloud account information, and photo metadata such as file names, the names of your shared photo streams, the names of people and the related information, including addresses, emails, and phone numbers from your contacts database, locations, objects and scenes in your photos, and calendar events associated with your photos and memories, statistics about your photo library such as counts and titles of photos, moments, and the age of your photos, information related to each of your memories, information about your recent or past Apple Music listening activity, so on, so on. So many sensitive data, right? And there is a protection that you need to press Enter to continue. And what is funny with this tool is that when you provide -H, you will see that, oh, so there is a flag. output file where you can specify all this diagnostic sensitive information will be saved, right? So just by using this sophisticated exploit, I was able to get all those data. So, but we have the enter protection, right? But just to bypass it, just echo pipe and run the tool, right? And that's it. And the proof of concept you can see at the screen. It was just like that. You open these, you execute this bash script. You can see the locations, the dumping caller ID, the dumped iMessage caller IDs, and of course full photo libraries. So that was fun. That was a really good tool, and it was like not even hidden, especially. Okay, so now let's talk about QuartzCore framework, which is a standard low-level framework built into macOS for processing and rendering graphical data. And generally, it will be loaded by all your macOS applications with graphical user interface. It doesn't mean it doesn't depend on programming language. Every application with user interface, it doesn't matter if it's Apple's application or a third-party application, will probably rely on this framework. And even if you use dilib-tree on AppKit, which is the standard framework used by applications, you will see that in the tree of loaded libraries, there is QuartzCore indeed loaded. So this is a sweet spot to hunt. And the QuartzCore framework, because this is the whole 2D drawing engine, it has a lot of functionalities and a lot of environment variables that can control the behavior of the framework. So there is really a lot of envars. But I spotted 2 or actually 3 interesting envars. The first one is QuartzCore log file or xlog file, because in the end those 2 envars do the same. And the second one is xlog file open. So let's start some reverse engineering to see what they do. So the QuartzCore log file or xlog file, when set to a file name, it will make your graphical user interface application start logging the QuartzCore events that were happening during the rendering of Windows. And whenever you set the xlog file open to 1, after you close your application, the log file will be automatically opened by the default text editor. Can you spot a bug here? I will give you like 5 seconds because we don't have much time. Any idea? Okay, so there is a string concatenation passed to the system command, right? So that means that we have command injection in all graphical applications on macOS with graphical user interface. This is really huge, right? So what happens next? So the system function will spawn a child process that will execute our command because we have the command injection. And the TCC is based on responsible processes. And because the child will be spawned by the parent who is TCC entitled, the TCC will grant also the permissions of the main app to the application we executed. And you can confirm it with such a command. So I just open findmy. I pass the QuartzCore log file with the command injection in here. And I set also xlog file open to 1 to make the operating system launch or open the file that was the log file that was created. And as you can see in Red Canary Mac monitor, the findmy eventually opens the say command I injected in here. So let's take a look at the demo. There is no tmp desktop ls file, so now I'm running my exploit. I will be using GarageBand to inject my command. It has been launched. Now the application, it closes the GarageBand and the command injection is triggered. So as you can see on the TCC prompt, there was information that GarageBand wants to access the privacy data, right? Because we inherited its permissions. And now you can see the TMP desktop ls file is filled with the ls of the desktop, which should not be possible. So yeah, this proves the TCC bypass. Great, so now let's talk about Core Foundation network, which respects a variable CF network diagnostics, when which set will make the process log every HTTP and HTTPS request. And you know what? It was in the Apple's documentation. I haven't reverse engineered it. I just read the documentation. So Core Foundation network is a framework that is used widely in the macOS. Even if you use a dilib tree on Foundation, you will see that in the end there's CF network framework linked. And whenever your application uses the standard macOS networking API, the CF network functions will be used under the hood. So most of the Apple internal apps were vulnerable to built into the macOS. So let's take a look at the demo. I'm launching Safari with this set, and everything by Core Foundation network is being logged. So what I was able to get, of course, like in here, session ID of my company's Jira was logged, but it was, of course, the injection in Safari. I also do the same injection in the maps, which, of course, need to know your location in order to show you where you are. So I was able to leak the location. Also, I used it on Find My, which includes the iCloud token, which can be used later to get your iCloud synchronized data. And as I proved in my talk, what happens on your Mac stays on Apple's iCloud. When you have this token, it's possible to derive the TCC-protected sensitive entries that are synchronized with iCloud. And they consist the data of Find My, contacts, calendars, reminders, notes, photos, iMessage, and more. Just to show you the demo, that it actually works, I coded a tool which takes the location. I pass the iCloud token. Under the hood, the tool refreshes the Find My location, and then it dumps your location directly from the iCloud. Now where you can see in that huge JSON, there is your location. So yeah, accessing this tokens is really bad for the TCC and your privacy. And the next slide is a bit hard because I want to be fair both with you and with Apple. I don't want to disclose any 0 days, and because that could harm you, me, and all Apple's customers. But in the very same time, with Chaba, we've made a submission to BlackHat where I promised that I will show you one more bug. But unfortunately, this bug is not yet fixed. I reported a major TCC vulnerability back in January 2023, and unfortunately, it's still unfixed. And I told Apple that I won't disclose this vulnerability in November 2023, so I think they have sufficient time to fix a major privacy vulnerability on macOS, but unfortunately, they didn't, so maybe on the next talk, I will present it. I will disclose it.
So let's quickly talk about how TCC is improved over the past 4 years. So some of the techniques we used in the past are actually dead or dying, going away. Mounting over directories was a common technique. Apple protected many files from being overwritten, read, whatever, but you could easily mount over the directory and either get the system to write a file in there again or drop a new config file, whatever. This is mostly gone. Apple learned the lesson. Many of the sysadmin tools which had very strong entitlements, They are either hardened or have been removed from the system. The plugin techniques, like injecting plugins to GarageBand, Imagent app, all sorts of application on macOS to gain access to their entitlements, that's mostly gone due to the launch constraint feature that was introduced in macOS Ventura. All the other apps are signed with hardened runtime. And instead of daemons loading external plugins, now it's basically moved into an external XPC service, which doesn't have any rights anymore, and that will load the plugin. So these are mostly gone. All the grepping, all the info leaks, I think file system-wise, they are almost gone. Really hard to find any new ones nowadays, and I think the log leaks are also going away. Also, the application data protection makes it harder because you don't necessarily have access to their container where there might be some private data. Also, the installer script bugs are mostly going away due to the new installer script action and mutation protection. Also, some of the improvements, launch constraints, this was not a TCC-specific mitigation. Basically, it will control who can launch an application, how can it launch, and from where can you launch an application. So for example, it was a common technique to take an application, copy it to the temp folder, maybe put in a plugin into this application and then launch it from there. This no longer works. So you cannot take an application, copy it out and launch it from there. Also, you cannot launch daemons from the command line, only launch them as a daemon and so on. This was a really, really good improvement, and I think it's a really great engineering effort from Apple. It makes our life harder. Also, the application bundle and data protection, probably that's the most impactful TCC protection since Monterey. It protects the application data and the application itself. At this stage, so it's nice, but it's trivial to bypass at this stage, which many of our bypasses are still being fixed. And again, overall, there are like 16 new TCC categories in Monterey. So as a closure, TCC is Apple's attempt to protect private data, which is not unseen in Linux or Windows environments. And in the past 5 years, it evolved a lot, really, and it's getting harder and harder to find vulnerabilities. So like 3 years ago, it was easy to find a generic bypass. Nowadays, you need to be creative and really tricky to find them. Still, only 2 of us, we could fill like 3 conference talks with just TCC bugs. And there are other people finding these as well, so that's not even included. So we said in the title it's final chapter. Yes, it's been a nice trilogy, good research, and trilogies don't get a 4th chapter. But what do trilogies get? A sequel. So we're happy to introduce Return to TCC Land. It's under heavy development, and hopefully we can present it next year, and we will bypass again everything. I think we already have enough content just for that talk. So yeah, hopefully next year. Thank you.
Are there any questions? Oh, there's one question, okay. You have a microphone in there.
So I'm Xuxiang. I'm just do TCC research and find some vulnerabilities. We just in 2 years ago we reported similar vulnerabilities, but I find it's very hard to use in iPhone or iPad because Apple Store just a big problem. Do you have any idea about this one?
A question to you or me?
Just the TCD bypass can be used in macOS and but it's hardly to use in iPhone.
Well,
Yeah.
that's good.
Oh, okay. So I think on iPhone, you don't have many of the features or applications you have on macOS, which allows you to bypass.
Yeah.
We specifically targeted macOS, but I know some of our reports showed up in the iOS advisory as well, so I guess they were applicable for iOS. I think iOS in general is much more locked down than macOS, so probably there it's harder to find these issues.
Yeah, and please keep in mind that on iPhone or on iPad or generally on iOS, you cannot that freely spawn processes like you can do on macOS. So the attack surface is a bit lower, right? It's a bit higher. Yeah, that was hard. Yeah. Are there any other questions?
Yes.
Okay.
Hello, Raymond here. Just wondering, in terms of, I saw some of the things like geolocations being sort of leaking. The question I have is, if you set your locations to be off, right? So you're supposed to not have all this data, whether it's in logs or whatever, right?
Yes.
Do you see any of this, like, even if you set it to off, it is still on? I mean, it is still sending, it's just, you know.
No, I didn't notice such examples. Like, if you turn off location services, your location should not be sent to Apple servers. So theoretically, such vulnerabilities should not exist.
What I'm saying is, it's not in the logs that this data is residing once you switch it off. Am I right to say that?
Yeah.
You haven't seen any of this. Of course, if you bypass if you have compromised the TCC that what you guys had done, then of course, you know, whether you set it to off or on doesn't matter. But if you set it to off, by right, those logs and those data should not appear at all, right? That means TCC works, I'm saying.
Yeah, that's good.
Thanks.
I think we are out of time. If you have any other questions, you can find us here.
And stay tuned for the sequel.
Thank you.